Greetings, fellow mathematicians. We're going to take a look at a short follow-up to the previous problem. Make sure you realize why this one is different from the last improper integral. The previous one was an improper integral from 1 to infinity. Here, we have the improper integral from 0 to infinity. Now this one is usually thrown in, or one similar to it, in a Calc 2 course to make sure that you're paying attention to details. So we're going to go through at some point what makes this one tricky and then how we fix that. Essentially, the problem occurs with trying to compare to the p integral, which is an improper integral from 1 to infinity. Let's go ahead and see what happens if we just start this without paying attention to details. We'll start this very much like the previous one. So we're going to have an idea maybe that we think our improper integral is convergent. From our previous problem, if we have an idea that our improper integral is convergent, we might want to look for something bigger, and we can find a bigger function by making the denominator smaller, so that's no problem here. We'll make the denominator smaller by getting rid of the plus 1. X over x to the 4th. And notice we can reduce that to 1 over x cubed. And this is where many students make some errors. Make sure you realize, even though the function is 1 over x to a power 1 over x cubed, this is not the p integral. The p integral is an improper integral from 1 to infinity. This goes from 0 to infinity. If you were to actually determine if this is a convergent or divergent improper integral, what you're going to find is this one actually is divergent. And this gives you a useless comparison. If the bigger improper integral is divergent, that says nothing about the smaller one. So this comparison doesn't work for us. Now, the trick that we're going to make use of, which usually deals with the lower limit being 0, is we're going to split that integral from 0 to infinity into two integrals. We're going to split it at 1. So let's rewrite this as the integral from 0 to 1 of x divided by x to the 4th plus 1. And then we add to that, and here's where the p integral comes in. Now we're going to add to it an integral from 1 to infinity. All right, this is a basic property of integrals that we've made use of before. And notice that is the improper integral from the previous problem, which we know this is convergent. Now, how we deal with the first integral there, I have no idea what this evaluates to. Maybe we can find an antiderivative and plug in and use the fundamental theorem of calculus, but this is not an improper integral. It is completely defined at both 0 and 1. There's no infinities there. There's no infinite discontinuities in that interval from 0 to 1 for that function. This is just a regular normal integral. Or in other words, this just comes out to be some number. You could use that in a numerical algorithm and get an approximation for it, but it's a number. Our comparison test would now work to here. So just to see that, now we can apply the comparison test like we did before. And as usual, we reduce that to 1 over x cubed. By using the same tricks here. So now with the lower limit being 1, this is a convergent p-integral, and we can determine basically the work from the previous problem that this part, the improper integral from 1 to infinity, is convergent. So how we finish this problem, the comparison test works to this integral from 1 to infinity. The previous integral from 0 to 1 is just a number. A convergent improper integral plus a number is convergent. So by using the comparison test to a slightly different integral, by splitting it apart, we reach the conclusion that our improper integral from 0 to infinity of x divided by x to the 4th plus 1, this is convergent. And it's convergent by applying the comparison test after we split our integral into 2. And again, the reason we did that, the lower limit was 0. We want to try comparing with the p-integral, which applies when the lower limit is 1. Hope you enjoyed this video. This problem is a little tricky, but hopefully you see how we fix that, and you can go on to solve it pretty easily. If you enjoyed the content, support the channel, like and subscribe.